Let's begin today's session. And what I'll do is I'll just share my screen. I'll just share my screen and we will start taking questions. So, first, I'll take questions that I had received on the email, and then we will go to the questions that have been posted on Google Form, and then we will take some queries that have been asked in the live chat. Okay, so let us do it. And I'm just sharing my screen. Right. So first question is has been asked by engineer Tosh Agrawal, and he had asked a query related to structural systems for hipped roof. So I'll just take up that query. He has shared one image, and this has been put on the email. So let me just take that picture. Right. So I hope this is visible. So his query is related to this structural system for this hipped roof arrangement, and what he is asking that what is the structural arrangement for this hipped roof made out of steel. So structural system is quite simple. If you see over here, this is sort of a ridge element over here. On these, this frame is, let's say, resting. Okay, then you have members over here. So this becomes your primary system, you can call it as, and then you will have this secondary system which you can call as rafters. So this becomes your secondary system all over. So the load transfer will, and on this rafter then you will have flooring, tiles, flooring, sheets, whatever you are doing. So if you are going for tiles, then tiles will be placed like this, supporting on these or transferring their load to these rafters. So this will be the structural system for this type of a arrangement. And how the load transfer will take place. So from this tiling or this roof uh, surface to these rafters, from these rafters, then partial load on this ridge and partial load on this element, and then this ridge is again supported on these. So finally load will get transferred to these corners. On corners generally you will have some column or you will have some wall corner to take the maximum axial downward maximum vertical thrust. Also, if you see in this image, and if I were to show you the cross section over here, what they have also added is that this is my ridge element, these are my uh, something like this, and then they have also added this tie. They have also added a tie over here. So why this tie is being provided? Because let's say under the effect of load, gravity load, this will have a tendency to open up. So when this has a tendency to open up, uh, to counteract that opening up tendency, this tie member will be provided. Otherwise, if you don't provide that, then the thrust that is generated at the corners will have to be taken by the element that is provided over here. Okay, so to avoid that thrust developing, you need to have some tie element, or if this angle is very steep, if this theta angle is quite steep, so I would say if theta is uh, steep angle, that means it's closer to 90-degree, you will understand this thing, that the thrust will be how much. So thrust will be, let's say, whatever this force was, this force times cos theta, whatever this force F was. So this F times cos theta. Now, as this theta approaches angle 90, your thrust will go on becoming lesser and lesser numerically. Okay. So generally in hipped roofs, what we try to give this arrangement. So we try to have this riser. Uh, we try to have a larger riser height, so that this angle theta is larger, so that the thrust is eliminated, or I'll not say eliminated, its magnitude is reduced. Okay. Yeah. Civil engineering software and site knowledge, he is asking, my question is that beam is offset near to column, not resting on column, but rest on near face to column in main beam. How to calculate moment? See, moment calculation and all those analysis, either you do it by some quick model, that is the best way I would suggest. So you can make a quick model like this, and then whatever your system is or scheme is, accordingly you can analyze and then find out the moments and forces. So I think the basic question about structural system has been answered. For analysis values, I'll suggest you make some small model to understand what's happening. All right. Okay. Next question is from. So now this question is has been asked on the Google form by engineer Sujoy Patra. He is a working professional and joining from Kolkata. So uh, he has put one. I think it's a comment, not a question, but I'll just put it over here. What he's saying. I want to express my query. As we all know that drawing is language of engineering, but in current market it is very tough, as number of candidates are very high. Freshers are lacking opportunities as a graduate, but sometimes after completing masters, they face them they face the same issue due to skill or knowledge. Express your opinion and guide, please. No, I didn't get you. What do you want my opinion on? You're saying freshers are lacking opportunities as a graduate. Sometimes after masters also they face the same issue. Yeah, so my opinion is that what you have said is correct. I mean, that is what is happening. That even after masters, graduate engineers may face issues. I think the major reason for that is lack of uh, on the job training or on the job internship sort of a mechanism that is usually missing in engineering curriculum. So if you go to any other profession like doctor or lawyer, they have to go or they undergo rigorous internships, isn't it? Doctor has to go. So a doctor as a fresh doctor, when he or she completes MBBS, I think 6 to 9 months or even 1 year they have to act as a resident doctor in some hospital, get associated with it. So they learn on the job skills. Even for a lawyer, if you see, they have a lot of practical uh, work that they have to do before they get this what they call as sanad in Hindi. I don't know what they call it in English. So before they get their practicing license to practice as a lawyer, they have to go rigorous sort of on the job internship and get associated with some senior, work at some court, etc. Even chartered accountants have to uh, work as interns or work as article uh, with some senior chartered accountant. So what I'm trying to say that as an engineer, we don't have this thing of interning anywhere, compulsory internship anywhere as in our curriculum. So what happens that as a fresh graduate, even after doing masters, we lack the skill or knowledge, and we lack the on the job skills are missing. On the job skills means the skills that you require to do things on the job. That those things are missing because we never do this kind of internship. So that thing, yes, it will be missing because in our engineering curriculum, internship model is not there. You just do your 4 years degree. Everyone is BE after that or BTech after that, or you do 2 years of masters. Everyone is ME or MTech after that. There's no role of any internship, so nothing to gain on the job. So yeah, that's a big thing that is missing, and that's why when we graduate as a fresh engineer or as a fresh postgraduate, we don't know what to do or how to do things practically, and that's why we will face these difficulties. So yes, that is true, and the solution to it is, I think, that you will have to spend time after your engineering or post graduation, uh, either do some internship with someone or try to learn these things, try to learn these skills as they are required to be done in an actual job. Yeah. So Joy Patra is saying how to gain the knowledge of drawing. See, drawing, I would say that as an engineer, drawing skills, I won't say that you need to have the same level of drawing or drafting skills as a draftsperson has, because he or she, that is a draftsperson, is expected to do much more uh, to make good for construction drawings or fabrication drawings. So I won't say that you should have the same level of skills, but yes, one thing I would say that as a civil engineer or structural engineer also, you should be able to have good command on any CAD software. So even as a structural engineer, any CAD, computer aided drawing software, you should have a good command. So maybe not as a, not the level of skills that are expected from a draftsperson, but enough of CAD should be known that you can sketch, you can prepare sketches, you can prepare some basic drawings on your own. This is also required because in any many times your 3D software that you use, like STAD or ETABS, there also many times what happens that you may face this situation where you have to make some DXF 3D model, or you have to make some DXF drawing, 2D drawing, and in AutoCAD, and then you will be needed to import it to the software. So therefore CAD skills will be required. So even though you are not preparing good for construction drawings, but because importing it to software like ETAB, STAD, you required those skills. So yes, drawing is integral. Learning any CAD related software is quite important and a necessary requirement for you as a structural engineer. So how to gain the knowledge? Just as I answered, maybe by doing some internships or learning um, these things, these software from online mediums or working somewhere. Those are the options to learn. Okay. Yes, Mr. Nihal Babu. Next question is from engineer Nihal Babu. He is joining us from Kochi, Kerala, and I'll just paste his question what he has asked. So he's saying I have a combined footing with four pedestals. Each of the pedestals have four different critical load combinations. How to size and design? The pedestal are in grid 2 row 2 column. In dead plus wind load combination, two pedestals are in uplift and two are in downward pressure. Also moments are acting. Pedestal is 3 meter high. So he's saying in elevation he has this type of situation in cross sectional view, sorry. And then these are his pedestals in sectional view, and in the plan view they are something like this, and there are four pedestals in a grid of 2 by 2, and each, let's say each of this pedestal has a different load. So what to do, so what you need to do in such cases is that, let's say these are the individual local axis of all these pedestals. xx or zz, whatever you want to call it as. I am calling them as xxyy right now. Just hold on. Yeah. So let's call these local axis right now as xxyy. So what's happening in this situation? His question is that each of these columns have different loads. Okay. He's saying four different critical combinations. I'm just taking a case where all these have four different loads and four different moments. Correct. So how to do such things? So first thing you need to do will be, and in this moment I am assuming that this has the effect of the pedestal height also. So he has mentioned that these pedestals are 3 meter high. So whatever horizontal thrust is there in the pedestal, that will also add to this moment. So when I am saying mxx or myy moments, I am assuming that these have the effect of that pedestal height as well. Now his question is how to do these type of things. So first you find out the geometrical center of this system. So geometrical center means whatever is this dimension, you will have to assume certain dimension to begin with. I'll first tell you a way to do it manually, but then also recommend you to do such things in software like Safe or Stat Foundation. It will be much more easier. So now what you do is that first you have to do this P by A plus M by Z, and you have to ensure that this has to be less than bearing pressure, bearing capacity, of soil. So now how will you calculate this P? So P is simple. P you can just algebraically take up all the P's together. How will you calculate this moment? So moment will have to be calculated as the net effect. Okay. So how will you calculate this net effect? So whatever are these moments, this you sorry. So for example, I was taking the xx moment to begin with. You will first take the algebraic addition. Algebraic addition means as per the direction of this mxx1, whether it is acting like this or like this, you take the algebraically add them. Okay. Plus you also need to add what? Plus you also need to consider the effect of these axial loads and their eccentricities that are there. So how will you do that? So for example, this P1 into this distance. Are you with me so far what I'm saying? Y4. This distance is Y2. So this is my global X, let's say it. So plus you will also have to take the net effect of this moment due to the load eccentricity. Do you get it? Okay. Similarly, you will also calculate the YY. So when you are going to calculate the YY, what you will do? So I am writing it over here. M net YY will be summation M YY1 plus till 4. And this time, let's call these distances as x1, x2, x3, so on. So plus P1, x1, again the net effect. So once you get these net moments, then you have the P by A plus M by Z. A will be the plan area of this entire footing. Z will be the respective section modulus of this entire footing. In this manner, you will have to first do this P by A plus M by Z less than SBC. Also, you need to do the P by A minus M by Z. greater than 0, you have to ensure. So this will enable you to do the plan sizing. Once you do that, then you will have to find out the pressures at in this footing, and then once you find out those pressures, then you will have to find out the shears, moments, etc. So this way you will have to approach this problem. This way you will have to approach this problem. Now the things missing over here will be that if the loads were equal, let's say, what I'm saying, a word of caution over here, that if the loads were numerically equal, P1, P2, P3, P4 were numerically equal, MXX1, MXX2, MXX, these were, let's say, counterbalancing each other, then things would have been simpler. But if the loads are quite different from each other, numerically different, and these moment values all are also quite different from each other, and their directions are also quite different, then the one thing that you will not be able to manually judge, or I would say it becomes very difficult to manually judge, will be differential settlement in these cases. Okay, so because you are combining this, there is a possibility that for dissimilar column loads, there may be some cases of differential settlements. Now, these differential settlements you will not be able to tackle, or you may not be able to do this manually quite well. Okay, it will become a quite challenging problem of plates and shells. So it's difficult to do this calculation manually. And if you are missing out on these differential settlements, what are you actually missing out on? You are missing out on the moments that are generated due to differential settlement. So because of such cases, or because of such situation, what I would suggest is to go for software modeling in such cases, when you have these types of combined footings with a lot of different column loads and very dissimilar moments. So my suggestion would be that you may do it manually, but then there is a possibility of missing out on some effects. So better to go with some software like Safe or Stat Foundation. Okay, in our course on foundation design, actually we have done such things, combined footings, where we have done it on Stat, sorry, we have done it on Safe, and it becomes quite easy that way. Okay, so that was my answer. Next question is from engineer Dinesh. He's from India. He's asking, I'm designing a pile cap for a G plus 5 story building. The reaction dead plus the reaction for four numbers of 600 dia piles are maximum compression 1920 kilonewton and tension is 600 kilonewton. As per soil report, safe load capacity of 600 dia pile is 2000 kilonewton and pull-out capacity is this. Can we allow the tension of 600 kilonewton, which is less than pull-out capacity, in pile for dead plus live combination? Okay, so he's saying that he has a pile cap, the reaction. So one thing that is not clear, that is this pile cap having four piles? That is not clear from the question. That is not quite clear. So I am assuming that, let's say, these single pile cap has four piles. Okay. So if that is the case, and let's say for dead plus live combination, uh, all these are 600 dia piles. I'm showing you the plan view. This is pile cap. So maximum compression in the pile is 1920 kilonewton and maximum tension in the pile is 600 kilonewton, and then the safe capacities are uh, 2000 kilonewton for pull out, and safe uplift is 1250. So can we allow the tension of 600 kilonewton in dead plus live combination? Yes, you can allow. You can allow because the maximum tension in the pile 600 kilonewton even for dead plus live is less than the capacity, safe capacity. So you can allow this. The only thing that you need to check is that let's say that this was one pile cap which had four piles, and let's imagine that these two piles were having compression, and in dead plus live combination, and these two piles were having tension. So although you can see that the numeric values are less than the capacities, so you can allow. But one thing you need to check is the differential settlement over here or the angular tilting. You need to check that. So what will happen, because two piles are in compression, two piles are in uplift, there is a possible, I mean, of course, there is going to be some angular deformation of this. I am drawing quite an exaggerated diagram, but you understand what I'm saying, okay? So this pile is compressing, this pile is lifting, so there will be some angular distortion like this. So this angular distortion value you should check. This angular distortion value you should check, and there are certain limits given to this angular distortion, allowed angular distortion in, I think, IS 1904. So you go to IS 1904, check for that angular distortion and ensure that it is within the limits. Okay, right. So that is what you should do. Otherwise, it's okay. So even though your dead plus live combination pile has 600 kilonewton uplift, but because it is less than the capacity, safe capacity of pile, we will allow it. Only thing to be checked is, only thing to be checked is angular distortion of the pile, and the limit has to be checked. Limit is given in 1904 IS. And how can you calculate this angular distortion, by the way? So maybe if you are using some software, you will know that what is the downward deflection of this point of your pile cap, and you will know the upward deflection of this point of the pile cap. Quite easily, you will be able to calculate this angular distortion, or you will be able to calculate this difference. And then that distortion is usually given in terms of delta upon this dimension, let's say L. So the distortion is given in this terms. So I think you can easily do that. Okay. Next question is from engineer Devlin. He is joining us from Oman, and he is a working professional. He is asking, and I'll just paste it. Oh, I have already pasted it. So this question is by Devlin from Oman. Can you please give some details for manually generating PMM curves for column? So personally, I have never generated them myself, but you can refer to some books. So one of the books I will refer will be book by Professor Pillai and Devdas Menon, Pillai Menon, that gives a process for construction of PMM diagrams, gives a process for PM interaction curve generation. So it, I think, gives two processes. One is for PMM, that is the 3D curve that will happen. 3D curve, three-dimensional curve, it will be a PMM curve. So it gives process for that also, as far as I remember. And so it will be a surface actually, and it also, there is also the process given for a two-dimensional PM curve. And if I just remembered that even in the ETABS documentation, ETABS, you go to ETABS frame design manual for RCC. So even in that document, they have given the process that ETABS uses for this PMM curve generation. Okay. Mr. Magaj is adding to that pile question. He's saying, uh, is it possible for uplift in dead load plus live load case? Yeah, it's possible. Let's say you had some very high moment. Let's say there was this column, and this column had a very high moment. Okay, this this column had a very high moment under the dead load plus live load combination. So it's quite possible that because of this very high moment, there is a uplift that comes on the pile. Yeah, it's possible. Okay. So those were the questions that were asked in the Google form. Now let us take the questions from the live comments. So there is this hello, and Mr. Sujoy Patra is adding to his earlier question. If possible, guide on how to make a checklist for ETABS modeling. So instead of me telling you, what you can do is you go to engineer Kunal Talsania. You go to his LinkedIn page. Okay, you go to his LinkedIn page profile, that is from the same spelling, Kunal Talsania, and he has provided, or he has uploaded, he himself makes those checklists. So there are some very good checklists that he has uploaded as post. So one of them is for stat modeling, one of them is for ETABS modeling, one of them is for if you are doing a building using IS 16700 tall building. So all those checklists are there. So I would suggest that instead of me making a fresh checklist, he has already made excellent checklist for various scenarios. So you go and visit his LinkedIn page and take it from there. Okay. Okay. Nice. Then we have another question from. So now I am taking the live comments, questions on live comments. So can I model and analyze water tank and retaining wall in STAD using plate model? Yes, you can do that. I have analyzed the combined footing in STAD and designed using forces from STAD. Is that process correct? So you have used STAD foundation for it. You have used STAD foundation for it. So all the see, yeah, you can do that. So even in STAD, you can do that. So even in STAD, there is an option to provide springs below the plate. So that option you can use, and you can provide the spring subgrade modulus in STAT Pro also. So that option is also possible. Okay, just plate model. No, you are writing over here, I have analyzed the combined foundation in STAT. So how did you analyze combined foundation in STAT? Or you wanted to write STAT foundation? Where did you analyze and design the foundation? That is my question. Anyway, so in the meanwhile, he's providing us with his reply. Can I model and analyze water tanks and retaining walls in STAD using plate model? Answer is yes, you can do that. So retaining walls and uh, tank walls can be analyzed in STAD also. It is just that STAD does not give you the moments and shears quite well, I would say. So it will give you moments, but when it comes to shear, it does not give you the shear forces properly. It only gives you the shear stresses. So that may become slightly complicated when you are doing work as a practicing. I mean, when you want quick shear force values, STAT gives you the shear stresses. So sometimes that becomes slightly complicated. But then Otherwise, it's okay. Yeah. Otherwise, it's quite okay. So Mr. Bharti is saying extracted the forces from plates and used Excel to design reinforcement. Yeah, you could do that. But it is just that personally, I feel the whole interface of STAD when it comes to plate is quite complicated, right from modeling to force application to load application to analysis, extracting those results. I find the complete interface quite complicated. That's my personal opinion. So when we did a course, or when the course that we have done on liquid retaining structures, we have deliberately done it on ETABS because I find StatPro interface quite complicated and quite lengthy. Uh, so yeah, I avoid doing it on Stat. Then engineer Padma Vijayan is asking, how do we consider the safe bearing capacity when rubble stones are filled over loose soil before placing isolated footings? So if you are placing rubble stones, I mean, personally, either you should find out the K value. How will you find out the K value? You conduct a CBR. So if you have placed rubble stones on loose soil, then ideally you should conduct a CBR, and from that CBR, then you can find out the bearing capacity and K value. So that can be one of the ways. Next process or next way can be to conduct plate load test. So you conduct an actual plate load test on that rubble strata on top of that, and then try to assess the bearing pressure, bearing capacity of your soil. Okay. So otherwise, judging it is quite difficult that way, and therefore, generally, what we like to do is to remove those loose or filled up soils, and then replace it with some compacted Muram GSB, something like that. So, in our personal opinion, when you remove the loose soil and when you replace it with compacted Muram, uh, and plus a little bit of GSB, let's say 100 GSB or 150 GSB, the usual bearing capacity that we have got usually is around 15-16 tons per square meter. But then it is quite, I mean, I would strongly recommend to do some geotechnical testing at that strata, especially if you are doing some important, if you are, let's say, going to put some footing which has got, or which is a crucial footing of your structure. I would suggest to also then assess the bearing capacity by doing some actual test. So either do a plate load test or conduct CBR and try to assess it. Okay. Then Mr. Bharti is saying, another question is asking, while designing structures supporting equipments, the equipment vendor provided me with seismic forces for the equipment. How to do the seismic analysis in the case for building supporting that equipment? See, the your equipment vendor has already provided you with the seismic forces. So that means the equipment supplier has done the analysis and they have provided you with the seismic reaction, so to say. So now what you should do is, in such a case, let's say this was your equipment and this was resting on legs, and then you had a beam RCC and RCC beam resting on column. So my suggestion would be that, let's say, for this direction of earthquake, you already have the reactions given to you by the supplier vendor. So you may apply them as forces, let's say. So instead of applying them as reactions, you apply them as forces, base force. So when you are going to make, let's say, a load case in your ETABS or STAD, whatever, so wherever you are going to define this, in that load case, under that load case, you put these values as your point loads or nodal loads or whatever, in whatever form the equipment vendor has given you these reactions, you apply them as forces. That means the direction should be like this. So if this EQS is acting, you apply them as forces like this. Okay. So you put it into the load case that you're defining. And I think that should be it then. All right. So you don't need to do the seismic analysis again. That has been already provided. That is one part. And then you will have to design these supporting structural arrangement, or I would say the supports that you are providing, that you need to design it in such a way. So maybe the equipment supplier has not given you. So the support has to be properly designed so that it can take the reactions and transfer it to your main structure safely. Okay. Okay. Mr. Magaj is asking next question. In pile design, depth of fixity to be taken as full depth of fixity or half of it? It depends on the soil strata. It depends on a lot of other things, but mainly on soil strata underneath. So you cannot say depth of fixity is full depth or half of it unless you do some calculations. Those calculations are given in depth of fixity for pile. Those calculations are given in IS 2911. If I remember, part 1, section 3, I think, if I remember correctly. 2911, part 1, section 3. There are in annexure C. I may be wrong over here. I'm not remembering. Or IS 2911 part 2. I'm not remembering properly which code. Some code of the 2911. It gives you that. And so what you can do, you go to that clause annexure C, and from there you can find out the depth of fixity. It depends mainly on the pile dia and the soil strata underneath. Usual value, if you ask me, would be somewhere around 5 to 7 times pile dia. So 5 to 7 times pile dia is the usual value that you get for depth of fixity. Okay, good. Engineer Salman Roj is asking, we design eccentric footing in safe footing pass in as raft foundation. Is it possible? No, eccentric footing if you are doing in safe, I don't know what you mean by pass fail, but you have to check the bearing pressure. So you need to ensure that bearing pressures are within the limit. Generally, if you have provided eccentric footing and there is no tie beam arrangement or there is no strap beam that you have provided, generally it will never pass in uplift check. Okay, so it will never pass in uplift check. So I don't know how your footing is passing. You need to see and ensure that bearing pressures are, you need to ensure two things: maximum bearing pressure less than SBC, minimum bearing pressure greater than 0. That means there should be no uplift and maximum pressure should be less than SBC. You do these things. Generally, if you don't provide strap footing or if there is no tie beam arrangement to take that eccentric movement, these two things will not pass. So just check that. Okay, the next question is from engineer Arbaz Kazi. He is asking, what is shear enhancement in one-way shear and how to calculate it in beams and raft foundation? What are drag beams in outrigger floors? Drag beams, I don't know. I'm not sure by this. I've never heard this term drag beams, so unable to comment. Shear enhancement near the supports, if you have seen your clause IS code gives you or allows you the shear enhancement, and it gives you this factor which you can multiply it by tau c. That factor is given as 2 AV upon D, where AV is the distance from the support at which your load is acting. So that shear enhancement you can do by multiplying the tau c by 2 AV upon D. Those clauses and provisions are given quite clearly in the IS 456. So either you take the maximum shear and then you're allowed to do the shear enhancement. by multiplying, as I just told you, 2 upon d, or you take the shear at d distance away from support. In that case, you don't design for critical shear, but you design for shear which is at a distance d from face of support. In that case, you don't do any shear enhancement. So those detailed uh, steps or detailed procedure is given in the IS code. Same thing you do for beam, same thing you do for any shear carrying element. Mr. Magaj is adding to his question. Geotech has given the depth of fixity. Yeah, so if the geotech has given you the depth of fixity, where is the confusion? You take that depth of fixity. So this depth of fixity will mainly come into picture when you are going to find out the moment in the pile. Let's say this is my pile and this was some pile cap, whatever. So when you have to find out the moment in the pile due to horizontal reaction, then what you do is that to calculate, you multiply this by the depth of fixity. So moment in the pile will be h times depth of fixity, and then you need to ensure, generally your pile geotech report also gives you the moment, allowable moment that one pile can resist. So you need to see whether that is less than this h into depth of fixity is less than that moment capacity of one single pile. It's quite a small value, but yes, you need to check that. And then whatever this moment calculated, you have to provide reinforcement for that. So then you need to design it as a column where you have the pile cross section, and moment in that pile cross section is horizontal thrust times depth of fixity. Also you take moment due to minimum eccentricity. So let's say there is some axial load acting, you also calculate moment due to minimum eccentricity. Now in this case, what I do personally is moment due to minimum eccentricity. This is the minimum moment, and how much will this eccentricity be equal to? So usually the same formula that we take for columns. What is the eccentricity formula for columns? I think L means the total length by 500 plus D by 30, I think. Yeah. So this gives you the eccentricity. You multiply this eccentricity by the axial load to take out the minimum, to get the minimum moment. So now you design your pile for the higher of the two. That means higher of this h times depth of fixity, or this, for higher of the two, you design your pile. Designing of pile means you find out the reinforcement in the pile and check the cross section of pile for that. Okay. Mr. Salman Roj is adding to his earlier question on eccentric footing. Bearing pressure is less than SBC if E, and then he stops. I don't know what. I'm not sure what he's saying. Mr. Arbas Kazi is saying, so if I am calculating one-way shear at distance D, I'm not allowed to Yeah, you are not allowed to multiply it by enhancement factor then. So there are two approaches given by the code. If you are checking for maximum shear value, maximum shear force, which is near the supports, if you are designing for that, you are allowed to increase the tau c value by this enhancement factor. That is one of the approach. Second approach is that you, instead of taking and designing for maximum shear, you take shear which is at d distance from support. In that case, you are not allowed to take the enhancement factor. Okay. Yes. Another question is from Mr. Dhodari, Suraj Dhodari, and he is saying, so I'll just copy his question, what he's saying, asking rather, and I'll just put it over here. Can you please tell us the recommended modifier for shear walls, spandrel, flat plate, drop basement wall, and wall with and without considering lateral load effects? That is so. I don't remember the numerical values as of now, but you can refer to ACI 318 for it. He has provided some pictures. So yeah, these picture. I mean, you just follow or refer to ACI codes. Numeric values. I don't. I am not able to recall, but you may follow ACI 318 for it, or you may follow IS 16700 if you are doing some Indian project on Indian codes. So IS 16700 does not give you separate modifiers for spandrel. For flat plate, you may use the same modifier that you have been given for slabs. 16700 also does not give a separate modifier for basement walls, and there is no distinction made as to with and without lateral loads. So the only distinction that has been made is whether you are checking for serviceability effect or limit state of serviceability or limit state of collapse. So in that I mean, as per that you can take the modifiers. Okay. Okay, Mr. Salman Roj is adding to his question. If I design eccentric raft foundation and check bearing pressure, we get less than SBC. Settlement less than permissible settlement. But you did not address my crucial point. Is there any uplift in your footing or not? Check that. Usually the maximum pressure will be less than SBC. That's not a problem. Usually that will be satisfied. But you check whether there is any uplift. For checking uplift, let's say if you are checking in safe, you see if there is any positive pressure in your raft or footing. If there is positive pressure in your footing or raft, it indicates there is uplift. You cannot allow uplift in your foundation. So that is the problem of doing eccentric footings. So you need to resolve that. Unless you do resolve it, you won't be able to. Yeah, is my voice audible? There was some internet disruption. Okay, Mr. Dinesh is saying, Mr. Dinesh is adding another question. He's saying, for corner or edge eccentric footings, some of the practicing engineers are giving pedestal so that they are saying changing CG of load. See, the mathematics does not get solved. What he's saying that some engineers do it like this in sectional view. So this is the eccentric footing. So they add this pedestal and they are saying that the CG now has been shifted like this. So now it's no longer eccentric. But if you understand, see, load transfer is happening over here. Now this thickness is not so rigid that a load that has been acted over here, you can assume that this thickness is so high that it becomes so rigid that it will behave as if the load is acting over here. No, that does not happen. So in my opinion, this does not work. That is my opinion. Physics wise or maths wise, you cannot solve it. or you cannot ensure that this is giving you a proper bearing, that this is giving you a proper maximum and minimum bearing pressure and satisfying all the requirements. It does not work in my opinion. Then how does it work on site? Because there are a lot of different issues which we don't consider usually. uh, so there is always this support from the adjacent plot. That means adjacent plots have some footings. We have a lot of safety margin in the bearing pressure capacity, safe bearing capacity that is given to us. So there are a lot of these margins which help these footings sort of work, but maths wise or physics wise it does not add up, it does not solve, you cannot solve it. You can do this experiment yourself. You assign this pedestal, let's say you're doing a safe model, you put this pedestal as some column property, and then you already have this column property given, so you analyze it and see it for yourself. Okay. Mr. Arbaz Kazi is adding over here that this is the misconception of old engineers. The old consultant do this, which is totally wrong, and when we will check in safe we will see the footing is in uplift. Yeah, that's what I was saying. The physics or maths does not get solved uh, even after adding this pedestal or doing such gimmicks. Okay, it won't work. One thing that may work, although you will require quite a lot of rigidity in that system, but I guess one thing that may work is something like this. So let's say you make this type of an arrangement. I'm showing you a sectional view. So what you are doing, this is your column. So somehow you are able to ensure that the column load acts like this on this element. This is the sectional view. Okay, this is my footing, and let's say this is my column. And over here, if you are able to do some gimmick or some arrangement where through which you can ensure that column loads act like this, what will happen? Part load transfers over here, part of the load transfers over here. Now this will create, let's say, movement in this direction, and this will get, I mean, you can counterbalance it by this movement from this tie beam. So this type of a structural arrangement may be possible. The difficulty in this is to ensure that the column load somehow gets transferred to this also and to this beam also. That is one of the possible scenarios you can think about. Okay. Yeah. Good. So I think all the questions are done. So we have taken up all the questions asked on email, through Google form, and also in the live comments. So till now we were taking sessions on Saturday evening. Today we are taking this session on Sunday morning. So what do you prefer more? Those who are joining live, that is. So till now we were taking sessions on Saturday evening around 7:30 p.m. IST. And today's session we took on Sunday morning 11 a.m. IST. So what is more preferred according to you? The live audience that are attending Sunday morning. Okay. Okay. So I think we'll try to keep next few sessions on Sunday morning. Let's see uh, if that works well or not. Okay. All right. So we'll try to keep our next few sessions on Sunday morning instead of Saturday evening. This Google form that has been shared, that is the same Google form uh, which is there to put all your queries. So you don't need to wait for the message to come and only then put your queries. You can put keep putting your queries in the same Google form throughout the week. Okay, I have put that link for Google form in the comments, and I am also showing it to you over here. So you don't need to wait for Sunday to come. You can keep on putting these queries in the Google form throughout the week, and we will discuss them once a week during the weekend. Okay, so that's all for this week then. Thank you, and we will see you next week, on a Sunday this time again, Sunday morning next week. Okay, thank you. Bye bye.